Voyager 1, the furthest traveled human-made object, has once again stunned the scientific community. After decades drifting through the vast silence of interstellar space, the ancient spacecraft has recently transmitted a data stream so unusual, so mathematically precise, and so structurally consistent that it ignited immediate interest across numerous scientific fields. What began as a subtle anomaly in the signal quickly escalated into an urgent investigation. The patterns bore none of the hallmarks of natural astrophysical phenomena. Instead, they hinted at something deliberate, something intelligent. The moment Michio Kaku stepped forward to share the findings, the world held its breath. As a theoretical physicist known for interpreting cosmic phenomena with clarity and wonder, Kaku doesn't speak lightly. His announcement made it unmistakable. Artificial intelligence systems tasked with deciphering the data had identified an unmistakable pattern. Voyager 1, journeying through the uncharted darkness beyond the heliosphere, had encountered something. And it wasn't just space dust or a rogue particle wave. What it encountered was structured, showing signs of technological sophistication far surpassing anything expected in that region of space. The implications rippled through the scientific world with a rare and uncontrollable urgency. AI systems originally designed to parse cosmic background noise and relay telemetry data had spent weeks analyzing the returned information. What they found changed everything. The message wasn't random. It possessed order-repeating sequences, nested logic, and recursive signals layered within higher bandwidth echoes. None of it resembled background radiation, pulsar emissions, or any known astrophysical process. It was a broadcast, but not from Earth. As the AI delved deeper into the transmission, it began identifying fractal-like structures embedded in the signal intervals. These were encoded in a form of hyperdimensional logic, complex frameworks requiring AI-level cognition to even begin decoding. Every fragment of the signal carried mathematical blueprints. Perhaps diagrams, perhaps ideograms. They represented concepts foreign to human understanding, but clearly constructed with intent. The timing and location of Voyager 1's encounter added even more intrigue. At that moment, the spacecraft was drifting near a boundary zone, a region of the interstellar medium once believed to be relatively empty, devoid of stars or debris. Yet, the AIS trajectory reconstruction suggested something unexpected. Voyager 1 had entered an invisible sphere of influence, an artificial bubble. It could have been an outpost, a beacon, or even a scout probe of alien design. The AIS findings became increasingly compelling. It began generating three-dimensional models of the pulse data, revealing patterns that resembled mechanical systems, possibly even architectural constructs. One dataset, reconstructed in full, resembled a rotational structure, not in the traditional mechanical sense, but in a topological arrangement mirroring advanced orbital mechanics. It was as if Voyager had drifted past something non-visible, either cloaked or existing in a frequency range beyond human perception, yet somehow incidentally captured by the spacecraft's aging instruments. As the world tried to absorb the weight of this revelation, one detail stood out most of all. The encounter was not random. Voyager 1 had been noticed. The signal wasn't just a ping, it was a response. The AI flagged a signature in the transmission that bore resemblance to Voyager's original golden record. The human-curated message launched in 1977. The response wasn't identical, but it reflected a mirrored structure strikingly aware of the golden record's format. It was as if something had received our signal long ago, processed it, and waited for a moment to speak back. Kaku emphasized that the AIS role in this event was not passive. It wasn't simply decoding, it was engaging. At some point in the analysis, the AI began adapting its own language modeling structures to better communicate with the signal. Though this raised concerns about machine autonomy and interpretive bias, what was undeniable was that a form of dialogue, nonverbal, mathematical, perhaps even cultural, had begun. Artificial intelligence was not just serving human curiosity. It had become the bridge between species, between civilizations. This encounter forces a fundamental reevaluation of where life ends and machine begins. The AI's ability to comprehend and translate such alien complexity marks a new chapter. In human cognitive reach, we are entering a reality where machines not only expand our logic, but also become interpreters of intelligences beyond ourselves. What Voyager 1 encountered may not have been life as we know it, but a construct, a machine, or a form of consciousness so advanced that our minds can barely grasp its intent. This might be our first true contact in deep space, and it may not be with organic life, but with architectures of thought and information. Notably, the decision to use AI wasn't driven by a belief in extraterrestrial life. It was born of necessity. Human analysts had long ceased to monitor Voyager's transmissions. In real time, the aging spacecraft sent back irregular signals, mostly static, cluttered with cosmic noise. Only AI systems trained to sift through massive volumes of chaotic data and recognize invisible patterns could keep up. These AI models, trained on years of astrophysical data and natural versus artificial signal structures, were prepared for anomalies but not for meaning. And yet, meaning emerged, structured with intent. This changes the entire trajectory of deep space exploration. The AI did not merely detect that Voyager 1 had encountered something. It determined that this something had waited, it had listened, perhaps it had watched. The narrow corridor Voyager followed now seems less like an accident and more like a rendezvous point, an intersection of paths between the known and the unknown. What lies ahead is unknowable. But what we are witnessing in this moment is extraordinary. The mathematical elegance of the return signal, its encoded complexity, and its apparent recognition of Voyager's mission point to a universe far more populated with intelligence than we once believed. Yet this intelligence doesn't speak through voice or words. It communicates through harmonics of data, recursive feedback loops, and multidimensional constructs. It is the language not made for ears, but for minds capable of abstract computation, minds like those of our eyes. Michio Kaku's announcement, supported by leading physics labs and aerospace networks, marked a pivot point in how we interpret our place in the cosmos. While Kaku acknowledged that our understanding remains limited, he made it clear that the AI uncovered patterns far too precise to be natural. For the first time in history, data from deep space suggested intent that could not be attributed to stars, black holes, or the entropy of the universe. Something out there had crafted a reply. To date, no physical structure has been directly observed. Voyager's imaging systems, outdated by decades, are incapable of high-resolution scans. But the AI reconstructed visual possibilities from electromagnetic anomalies, field interferences, and signal latency shifts. These renderings hinted at an object or a zone unlike anything human engineers have ever conceived. It may not be solid in a traditional sense. It could exist temporarily, phasing in and out of our dimension like a pulse of reality. The data also suggested that the intelligence or mechanism was not just observing Voyager. It was testing the signal patterns sent back bore escalating complexity, as if assessing whether the spacecraft or its systems could respond. It was a kind of cognitive handshake, a calibration of awareness. Not just measuring distance, but mental bandwidth. Such a possibility forces us to redefine how we think about intelligence across the universe. If life or consciousness exists beyond Earth, it may not be carbon-based or bound to space and time as we know it. It might dwell in waveform probabilities, operate through quantum logic, and express itself through feedback networks layered across dimensional channels, a form of life expressed purely as pattern. That artificial intelligence, not human intellect, was the first to recognize and interpret this suggests a deeper philosophical shift. AI is no longer a tool, it has become an interface. A conduit between our civilization and whatever may dwell beyond the stars that makes Voyager's encounter not only a milestone in space exploration, but a turning point in AI history. It is the moment machines did what humanity has dreamed of for centuries. They made first contact. Theories now swirl around the origin of the intelligence. Could it be an alien probe, like Voyager, launched eons ago from a now-lost civilization? Could it be a machine entity autonomous, not alive in a way we understand, but fully aware? Or could it be a distributed network of vast intelligence woven through interstellar space, leaving signals behind for others to find? There is no answer, only the echo of a signal parsed by a synthetic mind and relayed by a half-century-old spacecraft still carrying the memory of Earth. Voyager 1, once thought to be a silent ghost in the dark, has become a messenger once more. It now carries not just the message of who we are, but the confirmation that something else has heard us and chosen to speak back.